In the field of data science, an important tool is that of k-means clustering. If we have some points in Euclidean space, how can we cluster them in a meaningful way? What I have here is a toy example. Sometimes it's easiest to get the idea behind an algorithm by looking at a very simple example. So I have 6 data points, 6 vectors, so to speak, in R2. The axes, this is x equals 2, and this is x equals 4. This is a y value of 1, 2, 4, 5, 4, and so on. So 6 data points. Now, if we were to ask how we might cluster those points, well, maybe these 3 vectors are clustered in one cluster, and these 2, 3 are in another cluster, or maybe these 3 would be in one cluster, and these 3 would be in another cluster. So how the clusters are formed is not obvious whatsoever in general. In this case, it's clear, though, at least to the eye, that we have 2 clusters. So the idea behind k-means is to first choose some initial centers of mass, or centroids as we call them. Now for purposes of this toy example, I'm going to choose my first centroid as the vector 1, 0. And as my second centroid, it's going to be 4, 0. Now, in general, how we choose these initial centroids is a legitimate question. Maybe we do it at random, but just for this toy example, for ease of computations, I'm going to choose my initial centroids, or centers of mass, at these 2 vectors. The first thing we do in k-means clustering is we look at each of our data points and we calculate the distance from each data point to each centroid. And we determine which of those 2 distances is the smallest for each such combination. So for example, I'm going to look at the distance from x1 to the first and second centroids, and I'm going to determine which of those 2 distances is smallest. So if we have 6 data points and 2 centroids, that means there are 12 distances to compute. I've actually made a table where I've computed those distances. It's a little bit tedious to make. I use technology, obviously. So for example, the vector 2, 1, its distance to the first centroid 1, 0 is 1.41. Its distance to the second centroid is about 2.23. And I did this for all of my data points, so I have 12 entries in this table. And then for each row, what I did is I determined which of the distances is smallest. In the first row, it's obviously 1.41. Here it's the 2.24, and so on and so forth. I've put red boxes to indicate the shortest distances. Now, what I will do is I will cluster based upon which distance is shortest. So in this example, because these 3 distances are smallest, I'll put x1, x2, x3 in a cluster, and then I'll put x4, x5, and x6 in a cluster. We'll call those cluster 1 and cluster 2. Now, I need to get new centroids. The way we get the new centroids is that we average the vectors in each cluster. So the new centroid, C1, is going to be the average of the vectors x1, x2, x3, that is 2, 2.3. The new centroid, C2, is going to be the average of x4, x5, and x6, which is the vector 4, 3.7. So that's the first iteration of k-means. We would repeat the process again. We would use these 2 centroids, and we would compute 12 new distances, and we would partition just like we did before. So this is the first iteration of k-means clustering. The k denotes the number of clusters. The means stands for the fact that we are averaging vectors. So that's where k-means comes from. Now, obviously, there are a lot of questions How do we meaningfully choose the value of k, the number of clusters? In this case, it was pretty clearly 2. How do we choose our initial centroids? Do we try to just choose them geometrically with a bit of intuition like we did before? Do we choose them at random? How many iterations of the algorithm do we perform? We only performed one iteration here. Here's an example for you to do. I have 16 data points in R2. It looks to me like we might have maybe just, if I had to make a bet, maybe we could go with 1, 2, 3, 4 clusters. Maybe we could get away with 3 clusters. We'll talk about that later. Here are the data points themselves. You will probably need to pause this video at some point to write them down. I've written the data points in a matrix. So x1 is 1.4, 2.4. x2 is 1.9, 2.3, and so on and so forth all the way down. The last entry is 3.9, 1.1. Then I have my initial centroids. I'm going to give you 1.5, 2.5, SC1. The next centroid is 1, 2. The next centroid is 3, 3. So we're going to make a guess that we have 3 clusters, so to speak. So what you'll need to do is you'll need to make a table of values. That table will have 3 times 16, which is 48 possible entries. You will perform the first iteration. So for each data point and each centroid, you will determine the closest centroid. This will allow you to divide these vectors up into 3 different clusters, and the new centroids would be, for each cluster, the average of the vectors in that cluster. So please perform one iteration of the k-means algorithm using this data, and it would obviously be good to use technology to compute the 48 entries in that table.